All right, I've been getting a couple questions about how to do the graphing part of the lab that I just gave you guys. So I wanted to make a little video kind of just showing you guys what you need to do in order to do that part of the lab. So let me show you. Would have been nice if I was prepared and like ready to share everything already, but live and learn. That's not gonna work. Let me do this. All right, so I have my little document here. I made mine already, but just so you can see what we're doing. Did I not just click on that? Okay, I did not, is the answer. All right, so where is it? It's 8. Make a wave, oscillator, no damping. So we go back to our wave on a string, oscillator, no end, no damping, right? Just let it go. We get something like that. Excuse me. To collect the data, right? What you need to do is get out the rulers and get out the timer. Measure the vertical and horizontal location of a green ball. So there are quite a few green balls. There's 1, 2, 3, 4, 5, 6 of them. So pick one, and then you're just measuring the horizontal location, right, side to side location, and vertical location with respect to time. So a lot of times it can help to play it in slow motion just so you can actually see what's going on. But like, let's say you choose this green ball right here, right? So I'm going to pause the video. I'm going to press play on the stopwatch. And at 0 seconds, right, I can measure the horizontal distance of this green ball. Horizontal distance, we're measuring from the edge of this little orange line right here. So where's 0 at? There's 0. We can measure this here. Each one of the little hash marks is 0.2. So this is 2.2, 0.4, right about 2.5. So as you can see on my horizontal chart right here, right, I have 2.5 as the horizontal distance. And you'll notice, well, as we go on here, the horizontal distance won't change. The horizontal distance is going to be the same the whole time. So that'll save you a little bit of work right there. But the other thing we want to measure is the vertical distance. So vertical distance, we measure from, again, the orange line. This time we're going up. So here we would get 0.2, 0.3, 0.4, 0.5-ish, maybe 0.6, something like that. So in the time, I would have 0. Here I would have 0.5, 0.6, maybe 0.55, right? Halfway between, choose whatever. So at 0 seconds, there's my starting time. And then you can advance the frames using this little button right here. So maybe we go to, all right, I want to know every 0.2 seconds or something like that. So I'll go let this run for 0.2 seconds. Now the green ball is down here. So again, measure the horizontal distance from our starting point right there. So I'm going to put the 0 right on there. We see it's 2.5 again, so that hasn't changed. Vertical distance we would measure here. Now, vertical distance now, since we're below, we can't flip the ruler upside down, I don't think. Pretty sure you can't. So we're going to have to measure from the green ball to the orange line. Looks like 0.2, 0.3. So 0.3 right there. And this one, because it's now below the orange line, that would be a negative. So then I'd come over here, right? And at 0.2, I can probably just get rid of the rest of this because that's fake data now. All right, 0.2. Shoot. My vertical distance was 0.2, 0.3, negative 0.3. So there we go. I get another data point, negative 0.3. So then you collect the data right like that, right? Maybe we, because I chose 0.2, I'm just going to do every 0.2. So I let this play 0.39. There's 0.4, right? So I'm measuring the distance again. 0.2, 0.3, or sorry, 0.2, 0.4, 0.6-ish. About 0.6 now in terms of vertical. So at 0.4, seconds, we get negative 0.6-ish. And this one, you'll notice again, this one's still 2.5. So we get 2.5 again there. I could prove it to you if you want. Get this out of the way. 0.2, 0.4, 0.5. So there's that. So you make your little data table there. And then we do want to graph those as well. So if we copy, once you finish collecting all your data, you can copy that. Open up a Sheets document. I'm not sharing the right screen right now. Wait, am I sharing the right screen? I don't know. We'll find out in a second when I play this back to myself. So I have an untitled spreadsheet right here. You can see I got all the data that I collected earlier. And then I made using insert charts, right? A horizontal versus time graph and a vertical position versus time graph. You should get something of a curve for the vertical position graph. You should get a straight line for the horizontal position graph. For those of you that forget how to create the graph, you highlight the two columns that you want to graph. If you want to do vertical and time first, highlight them, insert, and then chart. Is that going to give me a whole nother chart? Yeah. And then you can pick what type of chart you want to have. I like scatter charts, so pick a scatter chart. You could probably also use like a line chart if you wanted to for this one to show the curve, but scatter charts are pretty much across the board what we go for in physics class. All right, so that's how you go about collecting the data and then turning the data into a graph. All right. Hopefully I shared the right screen, and we'll see in a second here that I don't have to re-record this. That'd be embarrassing if I was just sitting here and didn't realize that I stopped recording.